On March 7, 2009, the Kepler Space Telescope was launched with the sole mission of searching a thumbnail-sized portion of the sky containing 150,000 stars for planets. The data are in and are being analyzed, and a group of scientists has determined that our galaxy contains billions of Earth-like planets. Okay, so stars are really far away. We can only see them because they are supermassive fusion-powered light generators. So the idea that we can see, or rather detect, the planets around them is kinda nutso. Like, it was unthinkable 20 years ago, but it turns out we can do it. And there are a number of ways to do it, but Kepler does it by measuring the extremely faint dimming of a star as a planet passes in front of it. Kepler can tell basically two things. It can tell how much the star is dimmed and how long it takes for the planet to come back around to dim the star again. From those two data points, we can infer some wonderfully useful things. From the amount the star is dimmed, we can determine the diameter of the planet, and from the length of the orbit, we can determine how close the planet is to the star. We can figure out that last thing, by the way, using a mathematical formula figured out in the 1600s by, you guessed it, Johannes Kepler. Now, the most recent news here is that a group of scientists wanted to use Kepler's excellent data to figure out how rare Earth-like planets are. Here's how they did it. First, you pick out only Sun-like stars, since we don't really know how planets around bigger or smaller stars would function. There were 46,000 of these in the sample. Second, analyze the data for just those stars. They found 603 planets. Now, narrow it down to the planets that are roughly the size of Earth and orbit in a zone where water can exist, and voila! 10 Earth-like planets were observed by Kepler. Now, how do we get to billions from 10? Well, Kepler can only detect planets that pass between their stars and the telescope. Like, if you're the telescope and I'm the star, only if the planet is passing here can you actually detect it. And it's a tiny little speck compared to the star, to be clear. All that other space, like if the planet is rotating just up here, you never see it cross in front of the star. So the fact that it happened even 10 times indicates that, in fact, there are tons of Earth-like planets. Since the orientation of solar systems in the galaxy is random, we can take this into account and find that, in fact, about 22% of the planets surveyed had Earth-like planets. They just weren't including the star. Extrapolating this over all of the 20 billion sun-like stars in our galaxy, and yes, billions of Earths. Of course, to be clear, all of those Earths are unreachably distant, but since just 20 years ago contemplating even detecting them was unthinkable, maybe we're not so far off. The next step, of course, is to get a fancy telescope up there that can detect the atmospheric composition of some of these planets. Some scientists argue that a high percentage of oxygen in the atmosphere around a planet would pretty much guarantee that there was life operating on it, answering one of the deepest questions of human existence. Though, honestly, with a pool billions of Earths deep in this galaxy alone, I cannot imagine that life hasn't sprung up elsewhere, and good lord, what I would give to be the guy who writes the book on their mating strategies. Thanks for watching this episode of SciShow, and thanks to all the scientists doing this amazing work, blowing my mind. And of course, thank you to our subbable subscribers without whom we could not do this. If you have any questions or comments or ideas for us, we're on Facebook and Twitter and down in the comments below. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.